All right, welcome to lecture 25. This lecture is on liquids and solids. So you might remember the last couple of lectures, we've been talking about gases. We're kind of done with gases. So now we're going to move on to liquids and solids. Now you should know there's not quite as much information about liquids and solids you have to be familiar with. So this lecture, there's only going to be two parts. Part A, that's the one you're currently watching. We're going to talk a little bit about general properties of liquids and solids, and that's mainly going to be some vocabulary. And then we're going to move on to part B, and in part B, we're going to learn about something called intermolecular forces. With that, let's go ahead and get started with our discussion about liquids and solids. All right, to get started, let's just spend a few minutes talking about, well, why is it that some things around us in the world are solids and others are liquids and others are gases? Why do things exist in these different phases? Well, the main reason is that of determining whether you're going to be a solid or a liquid or a gas, it depends on the strength of the forces between molecules. Depends on how strong are the forces between molecules. Now these forces have a name. They're called intermolecular forces. Intermolecular forces. Now that's kind of a long word to say and write. So usually instead of saying intermolecular forces, I'm just going to abbreviate them IMF. It depends on the strength of the intermolecular forces. All right, so let's do a little, let's draw a little picture of what I'm talking about here. So we've already talked about what's going on inside of molecules. So inside of molecules, you know, you got like single bonds or double bonds or triple bonds. So we've already talked about in a previous chapter, well, for example, in water, water is H2O, and there's oxygen in the middle, and it's single bonded to the hydrogens, and the oxygen also has some lone pairs on it. So that's what's inside of a water molecule. Now, what we're going to move on to in this section is we're going to look at what goes on between water molecules. So if we draw up another water molecule, maybe I'll put one down here, there's actually an attraction, a force between these two molecules. So if you have a cup of water, you know, there's a bunch of water molecules and they're actually sticking to each other, right? If they weren't sticking to each other, they would fly off into space and they would just move around wherever they go, where they were wanted. But that's not the way water behaves, right? If you have a cup of water, they all stay close to each other. They all stay in the cup. So why are they staying together? Well, because there's an attraction from one water molecule to another. So I drew a little dotted line to represent that attraction. That attraction, again, is called an intermolecular force. So it's kind of like, I have a couple examples of water molecules here. This is one. All right, so this is like a representation of a water molecule. And here's another one. So there's some reason that they're going to stick to each other. And so they stick next to each other, they stick near each other. So why are they sticking to each other? That's what we're going to talk about in this chapter. Now, I should mention that these different intermolecular forces, they're not all the same strength. So if you are a really strong intermolecular force, that's going to keep these molecules, like water, really tightly and closely connected to each other. If the forces are a little weaker, that allows the molecules to kind of spread out more or to move away from each other. So when you have strong intermolecular forces, that means the molecules really stick to each other well. Now, what we're going to get into before we talk about these intermolecular forces and what they are, I'm going to spend a couple of minutes just telling you, well, like, why do we care about them? Like, what sorts of things do they control as far as the behavior of molecules? And it turns out that these intermolecular forces, they're responsible for a lot of the properties we notice for things. So let's just go through a few of them. All right, let me flip over. So these intermolecular forces control a lot about the way a molecule behaves. So for example, they control how easily a substance evaporates. So evaporation, that just means like a liquid turning into a gas, a liquid turning into a gas. That's what evaporating is. So there's lots of things in the world that evaporate slowly. There's lots of the things in the world where that evaporate quickly. So for example, things that evaporate slowly would be something like oil, like motor oil. If you spill it on your driveway and you come back, it's still going to be there. It's not going to evaporate, at least not very fast. So like oil evaporates slowly. Even water. If you spill water, you know, maybe eventually it evaporates, but it's going to stay on your kitchen floor for a while. All right, now there's lots of things in the world that, on the other hand, evaporate quickly. Like an example or two of that would be something like acetone, like that's fingernail polish remover. If you've ever used it, you know it evaporates right away when you put it on your fingers. Or even alcohol, like rubbing alcohol, it evaporates pretty quickly as well. Now, why is that? Well, it depends on how tightly those molecules are stuck to each other. So when something evaporates slowly, that's telling me that you've got, we'll say, strong intermolecular forces. So you're really stuck to each other. If you evaporate quickly, apparently you're not stuck as much to each other and you can go away, you can spread out, you can turn into a gas. So if you have weaker intermolecular forces, you're going to evaporate quickly. All right, let's do a few more properties. What else do these intermolecular forces control? Well, they also control boiling points. So some things in the world have kind of low boiling points. And some things in the world have high boiling points. Now, let me give you a little example or two here. Something with a relatively low boiling point, again, is like alcohol. Like rubbing alcohol boils at 60 degrees Celsius. Water boils at 100 degrees Celsius. So when I look at those numbers and I see, oh, you boil at a lower temperature, your alcohol boils at a lower temperature, that tells me it's going to have weaker intermolecular forces. And if you boil at a higher temperature, you're going to have stronger intermolecular forces. You're really stuck to your neighbors. You don't want to go and turn into a gas and escape from your friends. All right, so with that, let's do a couple more. Let's talk about a couple more things that these intermolecular forces control. Let's flip over. All right, let's talk about two more properties that intermolecular forces determine. One is surface tension. So surface tension is the resistance of the surface of a liquid to break. So for example, if you have a cup of water and you have a bunch of water molecules in that cup of water, and you want something to be able to sink down through that cup of water, something to go down to the bottom of that cup, well, to be able to do that, it's going to have to create a gap in between the water molecules. So if the water molecules are really close to each other, really connected to each other strongly, that's going to be hard for something to sink between. So that's kind of what surface tension is. So you might hear it defined sometimes as like, we'll say it this way, the film on the surface of a liquid. So sometimes things tend to have like a top layer that's hard to break through. The film on the surface of a liquid. Now, that film, that surface tension can be high or low. So things with a high surface tension, that would be something like water has a high surface tension. That tells me it's got strong intermolecular forces. Now, you can also have things with a low surface tension. Oh, those things don't resist things sinking into them. An example of that actually would be like alcohol again. And again, if you are easy to kind of break up and break through, that's because you have weak intermolecular forces. Weak intermolecular forces. So like a little example of this, you can actually take a cup of water And if you very gently, you put a paper clip on the top of the cup of water, the paper clip is actually denser than water, that metal it's made out of. So you would think that it should sink, but because of surface tension, it doesn't, even though it's denser than water. All right, one more term, viscosity. Viscosity is, well, it's actually, I'm going to write the same word in here. It's the resistance of a liquid to flow. So how hard is it to get some liquid to move out of maybe the bottle in your kitchen into your cup that you're pouring it into? Does it move quickly from one container to another or slowly? So viscosity is the resistance of a liquid to flow. So, all right, well, similar to what we just said, you can have things with a high viscosity. You can have things with a low viscosity. High viscosity, well, it should be an S there, shouldn't it? High viscosity is going to be things like, I don't know, syrup. If we kind of think about things in your kitchen, syrup doesn't really want to move. It resists flowing. And why would that be? Because the molecules are really stuck to each other. So syrup has a high viscosity because it has strong intermolecular forces. The molecules really stick to each other. They don't want to go anywhere. Low viscosity, again, that would be something like, I don't know, I keep using alcohol as an example, but that's okay, I guess. Alcohol, like rubbing alcohol, it moves from one place to another pretty quickly when you pour it out of the bottle of rubbing alcohol. Why would that be? Well, the molecules aren't stuck to each other, so they can move. So it has weak intermolecular forces. All right, so with that, that's kind of it for the vocabulary part of this. Let's go ahead and we're going to do a few practice questions on this topic. So let me go ahead and we'll flip over and do that. All right, so we're going to have our first little practice question. All right, so this one it says, which of the following is the most volatile? Which of the following is the most volatile? So, oh, I haven't mentioned that word to you yet. So let me tell you what volatile means. Volatile is just a word that means something that evaporates quickly, something that evaporates quickly. All right, so this is supposed to be like a liquid here, turning from a liquid into a gas. We're talking about that. So which one of the ones on this list, which of the ones of the following is the most volatile? Another way of saying that, which of the ones on this list evaporates the most quickly? So you're getting a little pop-up question here in a sec. Is it gold, vegetable oil, water, motor oil, or fingernail polish remover? Which one evaporates the most quickly? Which one's the most volatile? Okay, the one that evaporates the most quickly is, I believe, well, it should be fingernail polish remover. That's the one that evaporates the most quickly. So why would that be? Because it has the weakest intermolecular forces. All right, one more practice question, just to make sure this vocabulary, these terms made sense to you. All right, which of the following has the highest viscosity? Oh, that's another term I talked about. Do you remember that one? Highest viscosity. All right. Well, maybe the picture was a bit of a hint, wasn't it? Highest viscosity, that's the thing that resists movement, resistance to flowing, to moving. And that on this list is pancake syrup. Should have been, I hope you picked A for that one. All right, why? Because it has strong intermolecular forces. All right, so with that, I think that's it for this video. So in the next part, we're going to talk about what are these intermolecular forces and how do you tell whether they're strong or weak. All right, so that'll be in part B. So let's move on to part B in just a minute.